the setup. So remember when we're dividing, if I look at this 234 divided by 5, I could write this as a fraction this way, right? Or I could write it with an actual division sign this way. So what I'm getting at is knowing which one goes outside the little division house and which one goes inside, okay? The bottom always goes outside, or what follows the division sign goes outside, okay? So, of course, we're not going to be dividing easy ones like that. Ours are going to look something like this. F of x is 3x to the 4th minus 5x cubed plus 4x minus 6. And I'm going to divide that by another polynomial.
See, you talking about it was going to be easy.
I told you, Cameron told you, when you see it, y'all are going to go, oh my gosh.
Y'all tripping right now.
But when you see it done, you will feel better, okay?
All right.
All right. So, I need to tell you something before we start, because it's the first step in dividing all the time. It doesn't have anything to do with this one. And that's a placeholder. Okay? You have to be aware of what you have and what you're dividing by. And what I mean by that is, look at your exponents, okay? Look at the biggest exponent you have and make sure that you have every exponent from there down. In other words, this one starts with 4. So then I need to make sure, in addition to 4, that I have a 3. An exponent of 2. Do you see an exponent of 2 in there?
Yeah.
No. On this one, just this one. No. So I'm missing a 2. So what a placeholder does is it holds the place of any missing term with a 0. Because I can add 0 to anything, right? So this is not, I'm going to, instead of 3x to the 4th minus 5x cubed plus 4x, I'm going to make this 3x to the 4th minus 5x cubed plus 0x squared. That's holding the place of the exponent for 2 plus 4x minus 6. Does that make sense, what I did? I just threw a 0 in there to hold the place because I didn't have an exponent of 2. Do you all see that? Yep. Tell me when you're caught up with me. Look at the second one, what I'm dividing by. Do I need any placeholders in that one? What's the biggest exponent? 2. So I've got 2. There's an imaginary one there though, right? They're down. So 2, 1, and then the one without an exponent is the constant, okay? 2 is the highest. I went from the highest down. So I'm good on that one. Is everybody okay? Yes, just down. Yeah, because this is an imaginary one.
So if one side of the division sign got higher exponents and the other side don't have those exponents,
you don't have to worry about from one to the other. You just have to worry about each piece here like this. Like that one's got from 4, all right, here, 4, 3, 2, 1, constant. Then I go to this one. Okay, the biggest one here is 2. So I should have 2, 1, constant, and I do.
That's an S?
It's a 5.
Oh.
It's a 5. Okay, y'all all with me?
So you can bring that down?
Yep, so it's just the same. All right, so now let's set up. So tell me this. Using your 234 divided by 5 as a model, which of those 2 polynomials goes outside the division sign?
Huh?
I'm going to set it up like this. So for these 2, this is the one that's going to go outside my division sign. Okay, so it's going to be...
Now I remember this.
You remember? X squared minus 3x plus 5 goes outside. And inside goes the first one. Okay, so it's, and I'm not going to do the f of x. 3x to the 4th minus 5x cubed. Don't forget your placeholder. All right, 0x squared plus 4x minus 6. Here we go. Let's look here for just a second. If you were explaining to someone who had never done, Hayden, you don't look so pained. It's not going to be bad, I promise. Yes, but we're going to do it today and practice it tomorrow, okay? All right.
Wait, what's the test?
I gave it
Friday.
What?
All right. Look at this one. Look at this one. Tell me, if you're talking to a third grader who's fixing to learn this and you're trying to explain to them what to do, what is the first thing you tell them to do when it's set up like this? No, Aaron! How many times does 5 go into 23? In other words, what do you need to multiply 5 by to get 23 or as close as you can? Okay? And what do you do with that 4? Okay. Stop right there. I'm going to do the same thing, but this time I have a polynomial, okay? Now, the key is I'm only going to look at the first terms when I do this. What can I multiply x squared by to get 3x to the 4th?
3x squared.
3x squared. All right. Now, before you put it up top, I want you to think about this for just a minute. Think about this problem being divided into columns. Okay? Anything with an exponent of 4 is going to go in this column. Anything with an exponent of 3 is going to go in the second column, and so on and so forth. So, neatness is what's going to keep you alive here, okay? So, we said 3x to the second, so I'm going to go to this column with the seconds, and I'm going to put the 3x squared right here. What do you multiply x squared by to get 3x to the 4th? And it's 3x squared. So just like here where I wrote it on top, here I write it on top. Yep, we want to keep all the exponents together. It's going to help us out. Okay, is anybody confused so far?
Okay, why?
So that means if you got like 5x over, so that means if you got like 5x to the third over 0x to the second, you did something wrong.
Right, because they got to be lined up. That's exactly right.
Okay, how do we get 3x to the second?
All right, come back to this problem. You said, what do I multiply 5 by to get close to 23?
Oh.
After you put the 4 up there, what do you do?
Subtract it.
You're skipping a step. Bring what? The product. What's that mean? What's product mean? Times. That's what I want you. You got to break it way down. You're multiplying here. Do you agree?
Yes.
And then you're writing it down here. Do you agree?
Yes.
Sure.
Then you
Okay.
subtract. That's what I meant.
I know. All right. Shh, shh, shh. All right. So let's do it. We're going to take what we put up top and we're going to multiply it. Now.
Whoa.
Here's the thing.
The second one or the third one?
It has to go to everything. So what this becomes is 3x squared, guys, times, so it becomes like a distributing problem. X squared minus 3x plus 5, okay? It's got to go to everything because it's got to multiply to everything on the outside. This is why we spend so long multiplying polynomials and adding and subtracting polynomials. So watch. It is. 3x squared times x squared gives you what?
4x to the 4th.
3x to the 4th. 3x squared times negative 3x. Watch all these signs as you go, okay? Notice I'm lining them up in the columns in which they go. And then 3x squared times 5.
15x squared.
Same steps, more intense problem, but same steps.
So you gotta keep dividing?
All right.
You play.
So you get one number
Wait,
at the,
so-
on the top, and you just multiply it, that's the answer.
Not yet. We're not done. Are you done with this one?
Oh.
No. So you're not done with this one either. Tell me, after you multiply, this is probably the lesson that gets the most backlash from students when I teach it, but it is the one that everybody always goes back and goes, can we do some more of that long division stuff? Because I got that. That's a negative 9x cubed, yes. All right, look up here. You got to subtract. Now,
Bring the 4 down.
wait, y'all getting ahead of it. Subtract. Here's where you got to be careful. Am I just subtracting the first number? I'm subtracting the whole thing, which means when I get to this step,
Now you go to the 9. See,
I got to subtract the whole thing.
what's this guy doing?
Remember when we subtracted polynomials and we did same, change everything?
So everything that's in front is gonna end up being multiplied by everything in the center? Or is it always just gonna be the first term?
First term, first term. Now, when you multiply around, it'll be everything, but whenever you're looking at what to put up there, it's just first term. All right. Yes, go ahead, Hayden, ask me.
How come you put the 3x above the 3x?
Because it's grouped by their exponent. Shh, guys. All right. Same, change everything inside the parentheses.
Oh, hold on.
You just wait. Read one.
All right. I did a same, change everything. This is a vertical format. Y'all have been doing a horizontal format, but it's the same thing. Okay? What is 3x to the 4th minus 3x to the 4th? What is negative 5x to the 3rd plus 9x to the 3rd? 4x. We're just combining like terms here, y'all. Don't make it harder than it is. What is 0x squared and negative 15x squared? Negative 15x squared. I'm at the same point here now. And so several of you said at this point, wait, Miss McGee, drop down that 4. And you're right. That's the next step, right? We bring it down, and the whole process starts over. So look, bring it down, and let's start the process all over. There's too much repetition in here for you not to get it. It just starts repeating. What you got, Aaron? One term at a time. Just like if this had another number over here, you'd just be bringing one number down at a time and continuing on. Same thing, one term at a time. So now my question to you is, back to what we did initially. What do I multiply x squared by to get 4x to the 3rd?
3x? 2x?
Multiply.
4x.
4, because 1 times 4 is 4. And how many x's do you need?
1.
So I need a 4x, right? Positive or negative?
Positive.
So up top, I'm going to write plus 4x. The process is repeating now. I just looked at first terms, John. What if I have x squared? What can I multiply x squared by to get 4x to the 3rd? First terms only. 4x, okay? All right, once you write it up top, what do you do? Once you write the next number up top,
Screen that up.
multiply. You're exactly right. Multiply, right? When you write a number here, you multiply it around. So I'm going to multiply it around. But here, I got 3 things I have to multiply it to because there's 3 things outside. 4x times x squared is what? 4x cubed. 4x times negative 3x. Negative 12x, exactly. And 4x times 5, 20x.
I don't see a 5 anywhere.
Which 5?
4x times 5.
4x times 5 is 20x.
Where did the 5 come from?
This number on the end here. I did 4x times everything on the outside.
It's 3x over 0x.
Yes, yep. All right, shh. I'm going to subtract now because that's what I do when I multiply around. Because I subtract. But I have to subtract everything. And when I subtract a polynomial, that means I'm doing same, change, 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 change. Yes?
No, I don't understand.
I'm subtracting. So if I subtract, I do same. This is same. I changed the subtraction to an addition, and I changed all these signs. What is 4x cubed and negative 4x cubed? They're gone. What is negative 15x squared and 12x squared? What is 4x and negative 20x? Tell me what I do now. Bring down the next term. Do you see the repetition happening here? It's the same 3 or 4 steps over and over and over and over again. That's 3x squared, yes.
You gotta keep going to that.
You got to keep going until there's nothing left to bring down, just like you would with this problem. Okay? All right, y'all stay with me. Shh, 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 shh. Again, the process goes again. First terms only, what do I multiply x squared by to get this time negative 3x squared? Negative 3. It's x squared now, and I need it to be negative 3x squared. So I need a negative 3. Okay.
Put that, bring that.
David, wake up. I'm teaching. Multiply around. Here we go. Negative 3 times x squared is negative 3 times negative 3x, positive 9x. And negative 3 times positive 5. I told you it's 3 times 3. Negative, oh, yeah, negative 3 times 5.
And then you same change.
Yeah. The what? Where'd the what come from?
It was already in the problem.
I'm multiplying to this on the outside here.
It's on the color.
I know, I'm sorry. That 3 up top, multiplied to everything on the outside. That 5's on the outside. All right, same. Change. John said change everything, so we're going to change everything because John's always right. All right, first terms. If the first terms don't cancel out for you, you've done something wrong. The way we've set it up, it should always cancel. So negative 3x squared and 3x squared cancel. What is negative 16x and negative 9x? Negative 6 and 15.
39.
Negative 6. The 6 is negative. The 15 is positive. 9. Now, hold there for a minute. I don't have anything else to drop down. Right?
You got it.
So which one's the
Okay, so somebody said remainder and you're not wrong. But I need to express it the right way, so let me show you. If I have this 6 here and multiply around, I get 30. 4 is my remainder, right? And when we first learned remainders, you probably went up here and put 46 R4, right?
Yeah.
There's another little more sophisticated way to do it. Do you remember what it was? What you can also do with this remainder? Huh? Besides decimals, not decimals and zeros.
Write it
Write it how?
next to the number.
You're close. Have you ever seen it where you add it as the remainder over what you divided by? So it's 46 and 4/5.
You seen that one?
Okay. What you should have had a teacher that showed you that. You should have, because that's technically what it is. If you added a decimal and a zero, you'd get 0.8, which is 4/5.
Cool.
Okay. But what we do is we take this remainder. That's right. We put it over what we divided by. Okay? So it looks a lot worse than what it is because I just wrote what was already there. That's the answer. 3x, when you divide these two, you get 3x squared plus 4x minus 3 plus negative 25x plus 9 over x squared minus 3x plus 5. First things first, do you need any placeholders in this problem?
You missed the part where it looked like.
I know, they're not all set up like that. Yeah.
That? There's none
Just
of that?
make sure that what's after the division sign is what's on the outside of the little radical house, division house. All right. First things first. What do I multiply x by to get x to the third? Do we all see where x squared comes from? No. X times what gives you x to the third? How many x's do you need? 2 more x's, right? So it goes in the column above the squares. First term only. X times what would give you x to the third? What needs to go where that question mark is to get x to the third?
There's 3. You gotta get 3 of them.
So it already has 1, so how many more do you need?
So you're adding.
You adding exponents, yes.
Good. Then why is there a multiplication?
When you multiply terms with the same base, you add the exponents. That's that exponent property. All right. Shh. Multiply around. X squared, remember though, it's got to multiply to everything here, okay? So x squared times x is what? X to the third. And x squared times negative 2 is negative 2x squared. Anybody confused about that?
We're always subtracting.
Huh? All right, so explain where I got what's down here. Multiply, so x squared times x is x to the third. And x squared times negative 2 is negative 2x squared. All right, I'm going to subtract.
So you're always subtracting?
Always subtracting. Shh, guys, I feel like I'm fighting for your attention now. I know it's been long. I'm almost done, I promise. Same. Change. 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 Change everything on the bottom. Yes. Every single time, the first one should cancel out. It should happen every single time. What is 5x squared and 2x squared? What do I do now? Bring it down. This is a negative 7x. Be careful. Because this, okay. So now my question repeats. First terms only, what do I multiply x by to make it look like 7x squared? You were right, 7x. Positive 7x, right? It goes here. You with me, Hayden? Okay. Multiply around. You see the repetition here? We're just doing the same thing over and over and over.
You get 7x
7x times x is what? Mm-hmm. And now 7x times negative 2.
So, you did 7x.
I multiplied it to everything on the outside here.
Oh, I think I got it.
Yep. You got to change all those signs on that second row. That's right. Change, change, change. First terms. That's right. Negative 7x plus 14. That's correct. It's positive 7x.
And then x times 7. It's 7x again, isn't it?
Because wait, you forgot to do something.
Oh, we gotta bring that.
All right, is there anything we can do at this point?
No.
Guys.
Yes. No.
Oh.
You got a remainder. You gotta add.
Wait. Can you multiply x by anything to get 7x?
Yes.
Yes. 7. Just 7.
Sorry.
Right? 7 times x is 7x. So put a 7 up top.
But why? If there's nothing over here.
Because you just brought it down.
Sorry.
It's okay. Because I'm not looking there, I'm looking here.
Okay, so mark on it.
But you don't have anything to bring down from that.
I brought the 2 down. All right, listen, guys, I need y'all with me. Samara, put that away. Trillian, put that away. Your computer. I know.
So very cool.
I hadn't given it to you yet.
I think I got the answer.
All right. Does everyone see why I am not done yet?
Yes.
No. Okay, look. X times what gives you 7x? 7. That's why I put the 7 up here. Now I'm going to multiply it around. 7 times x is?
7x.
David, way to join us at the end. 7 times negative 2.
Negative 14.
Sine times the time.
That's exactly right.
You get 6 times.
And what is that, Cameron?
The answer will be x squared plus 7x plus 7 and then the x minus 2 over 16.
Let's flip it around. 16 over, but good job. X minus 2.
No, you put plus.
I think I
Negative